Well, as I mentioned earlier, my name is Jessica Hesselgrave, and I am fortunate enough to work at Vernier Software Technology with today's presenter. That's Nüsret Hisim.
Yep.
Okay,
I
got it.
Nailed it.
Thank you. As we refer to him here at the office, we call him Nüs. And so to start off, we have a few housekeeping slides that I will go over. And so a little bit more information about that community. It is called Teaching Next Generation Scientists. It's free, which is awesome. And so there's a lot of benefit there. There are edWebinar recordings, so not only ours will be available, but others who have done a webinar in this community, you'll have access to those recordings. You'll earn CE certificates. You'll be able to download slides and chat logs. You can join online discussions and get other free resources. All right. And so what we have today is our webinar called Using Technology to Excite Students About Hands-on Science. We at Vernier are excited to be here. Vernier Software and Technology, we know that classroom technology has to be easy. It has to be easy for teachers and easy for students. Our company was founded by a science teacher in 1981, and creating technology that is intuitive and built for the rigors of science education is our top priority. Vernier pioneers award-winning interfaces, sensors, software, and curriculum to enhance STEM education. Our hardware, software, and experiments transform how educators teach science and how students collect, analyze, and interpret scientific data. So now I'm going to go ahead and pass over the webinar controls to my colleague Nüs, and we'll go ahead and get started.
All right, hi there. Let me see here. I'm learning the interface here a little bit. Just a couple little things about me, just for those that might be curious. I taught in Maryland for 34 years. I used Vernier technology for about 30 of those years, so I've known David Vernier for a long time. I continue, even though I'm now working at Vernier, I continue to do lots of STEM activities in the community. I volunteer at the Science Museum. OMSI is the Oregon Science Museum. I also volunteer in classrooms and going to an elementary school tomorrow. So what we're going to do today is we're going to take something that hopefully is somewhat familiar to everyone, and we're going to see how that works, and hopefully I can show you how easy it is. So that's where we're headed. First thing we're going to do is just find out a little bit about you all. So there's a little poll going to come up on the screen, and just give me an idea of who is my audience, right? I'm just curious. So let me see. I love this. I remember clickers. I used to have these clickers a long time ago, and this sort of thing used to happen in my classroom, but this is even more cool. So let's see. So a lot of teachers. I like that. Look at that, man. Very good. Okay. So as you can see, the poll is leaning a lot towards teachers, and that's really good to know. So what do you think, Jess?
I think that's pretty cool. We also have people putting their title in the chat. So some librarians as well. Yeah. It's good to see a variety of folks from all over the country, and actually, I thought I saw some folks coming from around the world too. So that's excellent. So really good. So it looks like we have a lot of teachers. That's wonderful. Tech coordinators and stuff. There's some technology involved, and I will certainly talk about that. But yeah, definitely. I was hoping we would see a lot of teachers, and it looks like we are. So I'm going to go ahead and move on a little bit here and see what's going on. A couple of things. Why are we doing this, right? And so. Hands-on data collection. How does that work? So we're going to definitely be seeing that today. Pedagogical methods. The idea is when you're teaching these concepts, how does this
the use of this help in the pedagogical methods. And then I've done a lot of workshops, and the teachers frequently ask me about how does what you're doing align with national standards. So we will certainly touch on that a little bit. I have some correlations for you for NGSS, and so those will be available, and we'll talk about them just a little bit. So just to kind of let you know what's going on. First thing I wanted to make sure, because it's not always, I'm not always certain, is what is probeware? What is this thing? You know, how does it work, and that kind of thing. And I'm curious to know if what you guys think of what probeware is. So, you know, probeware for us, it creates, or at least it gives the students a chance to deepen their understanding of science. Probeware is very engaging. You should have seen those fifth graders last week. And so the students very frequently love working with probeware. Teachers can use this to help students analyze data in a different way, maybe, than something is just straight out of a book or on a worksheet. So that's just kind of a basics of what probeware is all about. And so another little poll here, just kind of curious, like, do you use probeware in your classroom? And so just kind of curious, like how many people do use probeware? Are you currently using it? Kind of interesting to see. You know, we talked about it at the office. You know, how many folks in this audience will have seen probeware or used probeware, and you can see the poll popping up here. And so what I'm hoping is that as a result of this presentation, that more of you will see the benefits of using probeware. And this is kind of a neat distribution there of folks that have not used probeware. So that's pretty cool. Yeah, it's interesting. I don't know exactly how many folks are actually in the webinar right now, but you can see about 100 folks have voted. And so that's, when you talk about percents, that's kind of nice. and so you can see that we're overwhelmingly haven't used probeware. And so we'll use some probeware, and then we can talk later about, you know, how you might apply that to what you're doing. So let's do an experiment. Okay, and so what I'd like to do is I'd like to do something that you're all familiar with. What do I need to do something now? Okay, that's exactly what I wanted. Thank you, Jess. You got it. I'm going to stand up and act like I'm really teaching. And so Jess is going to adjust the camera for me here. And what I'm going to do is I'm going to do an experiment that is not going to surprise anybody. Okay, I hope. We'll see. Okay. One of the things that we're going to do is we're going to use materials that you can easily get. So I hope that for a lot of folks, this is not surprising. You know, the baking soda and vinegar. I mean, if you asked your students what happens when you mix baking soda and vinegar, I would be surprised if too many students didn't know, you know, exactly what's going to happen. So I'm going to take a measure. Let me show you what I'm doing so you can see it. I'm going to take a measure of baking soda. So here's a measuring spoon. This is we're near Portland, Oregon, and so this is a coffee measuring spoon for measuring coffee out. Put that in a baggie, okay? And then what I'm going to do is I'm going to take a measured amount of vinegar. So I've got a bathroom cup here. I'm going to fill that with vinegar. Let me do that. So I'll measure out, and it's important. We're going to talk later about designing experiments. So it's important that we do this reproducibly. So I've got this full bathroom cup of vinegar. I'm going to hold this over my splash tray because you never know. Okay, you may notice I'm wearing goggles. That's also important when you're doing experiments like this. All right, so I'm going to put the vinegar in the baking soda. I will see if anyone is surprised by what happens. Okay, let me hold it up for everyone to see. And I would be surprised if too many of your students didn't realize that's going to happen. But our interest today, at least my interest today, is I'm touching the bottom of this bag, and I notice that there's a change in temperature. And what I'd like to know is, well, how much did that temperature actually change? Now, we talked about asking you all, you know, like, what do you think? Did it get hot? Did it get cold? I will tell you right now from experience with my students, I used to do this experiment every semester with my students. most of them will predict that this got hot because it bubbled and fizzed and made all this gas, and so they will predict that the baking soda and vinegar gets hot. So let's keep that in mind, and what we're going to do is we're going to switch over to measure this change in temperature and also make some predictions. And then further, what we're going to do is we're going to extend the experiment to another situation. So that's the plan. That's what we're going to do. So let me put this baggie out of the way. I'm going to sit back down again because it's a little more controlled when I do that. And this time what we're going to do is we're going to measure the temperature, but we're going to use a temperature probe. Okay, so Jessica's going to adjust the camera here so you all can kind of see what's going on. And I am going to take the data from this probe and I'm going to project it on the screen. So let me share my screen with you guys so you can see what I see. So let me bring it up here. And so let me switch the screen a little bit so you can see what's going on. Here's the temperature probe right here. And let me make sure that you guys can see it. And it's connected to my computer, and there's the live data here. I'm holding the end of the probe here so you can see that the temperature is changing when I touch the end of the probe. So I'm going to do the experiment very similar. The measures are going to be identical, but what I'm going to do is I'm going to do it in this styrofoam cup. And so I'm going to take my my baking soda and measure it out again. So here's my baking soda. This is a controlled experiment. We want to make sure that we do very similar amounts. Depending on the level of your students, you might choose to weigh the baking soda rather than using a measuring spoon. But you can see that's very close to what I was using before. I'm going to put the temperature probe in the baking soda. Let me switch my screen over to the graph. And we talked a little bit at the end of the baggie demo about is this thing getting hot? Is this thing getting cold? I will tell you that from experience, my students have pretty much, unless they knew in advance, pretty much guessed that it was getting warm because it was bubbling and fizzing. So with the software, what I can do is I can actually add a prediction. I can say, well, what do I think? And like I said, most of my students would predict, especially if they've never seen it before, that the temperature was going to go up. So I'm going to draw a prediction. And this is kind of an important thing for students to do. Try to use a little prior knowledge. Try to pull out of them what they already know. Students may know something different, and they can certainly make a prediction for that, but I'm going to leave it like that because this is from my experience, especially with younger children. They see all those bubbles and they think, oh my gosh, this thing must be getting warm, okay? So I've got the cup with the temperature probe in it. You can see the probe. I'm going to use it as a stirring rod. And so the probe is in the solid. I'm going to measure out my vinegar exactly the same amount. Okay, and once again, depending on the level of students, if you're a middle school or high school teacher, maybe you have access to graduated cylinders and things like that. I'm going to start collecting data. So I'm going to tap on this button up here that says collect and start collecting data. And you should see a little inchworm cutting across the screen there. That's the temperature of the baking soda in the styrofoam cup. And now let me put in the vinegar and let's see what happens to the temperature. I'm going to use the probe as a stirring rod. Of course, this reaction does elicit a lot of amusement in younger children particularly, but actually I have to say, even in my high school class when we would do this, you'd usually get a few people that would get pretty excited. If you look on the screen, you can see that the temperature did not what most people would have predicted. The temperature is going down. And so you can follow the progression there. I'm going to give this a few more stirs. Okay, and so for most people that have never actually measured it, they usually find this as a little bit counterintuitive. You know, it's like, wait a minute, bubbling and fizzing, shouldn't that be getting hot? Well, I tell my students, doesn't really work here because we're measuring this and it's not getting hot. If anything, it's getting colder. You can see in the bottom corner here, there is a temperature 17 degrees, and you might remember it was in the 20s when we started. Once the temperature has stopped changing, so if I look at this bottom meter down here, you can see that the temperature is 16.9 now for a few seconds. I'm going to go ahead and stop collecting data. Don't have to wait. The software will stop after a prescribed amount of time, in this case about 3 minutes, but I stopped it here. And then what we would like to do is now go switch over to some graph reading skills. And so what we can do is we can take our graph. I mean, but I'm going to get rid of the prediction because we don't really need that anymore. We know that that prediction wasn't quite right, so I'm going to take it off. And I'm going to go ahead and just zoom the graph here so that we can see how the data changed. At the beginning, the temperature was 25.0 degrees. I'm actually going to put a little note on the screen here so that we don't have to try to remember that. So I'm just going to put a little note on here, 25.0 degrees. So that way, you know, it's going to be on there for us so we can remember that. And then at the end of the experiment, when the temperature had stopped changing way over here, we can see the temp. I don't know how I planned this, but the temperature is 17.0 degrees. So I don't know that we really need another annotation, but I'll stick it on there just so it makes the graph look pretty. So it's all built into the software. It's not very magical, but it's very nice to have all these features in this software. And so there we go. So now the next thing to do is I always ask the elementary kids, the temperature started at 25 degrees. The temperature ended at 17 degrees. How do we figure out how much the temperature changed? And then usually if I drag it out long enough, I can get the students to talk about subtracting. And sometimes I'll ask them, I'll say, do you guys know anything about subtraction? They love to tell me that they do. But then the other thing to think about with this, and this is once again, it's going to be your call in your classroom, is in chemistry particularly, when we're looking at changes, we very frequently want to talk about what the condition was at the end minus what the condition was at the beginning. That's a common way to calculate how a change occurred. The final temperature minus the initial temperature. That does cause some consternation in the third grade class I was just recently in, because I was told you can't subtract a larger number from a smaller number. Okay, so you know that's another thing to talk about. It depends on your level of your students. So you can see that with you doing it this way, the students get some experience with reading a graph, getting the data from the graph, and then applying a simple mathematical application to analyzing the data. Now, the thing to think about is, well, is this the only thing that's possible? Well, of course not. There's lots of different chemicals that might be available to you in your classroom or in the house. We'll talk a little bit about safety after we do the next one. But I do have a chemical here that's remarkably common. You may or may not be familiar with it. It comes in a couple of different formats. It's called calcium chloride. Calcium chloride comes as commonly used, especially you guys in the East and the North. You probably know about this more than us folks out here in the West Coast. But it comes, people throw it on the sidewalk. It's a de-icer, melts ice and snow. You can also buy it this year. Let me show you a bag here. This is damp rid. People put this under cabinets to absorb moisture. You can put it under your sink, or you can put it in a closet or something if you want to keep it dry. I was surprised, I have to admit, that I didn't even know this until I started working on this presentation, that you can also buy it from a beer and wine making place. So here's a couple that I got from beer and wine making places. I had no idea, because I'm not a beer and wine maker. Maybe as I live here longer, I'll start to think about that. But it's used to change the pH of beer and wine. So these are food grade. I'm not suggesting anyone go out and eat this, but these are food grade calcium chloride. So I'm going to use the damp rid simply because I got that at so easily. I just went to Ace Hardware, picked it up. It was so easy. And so now here's what we need to do. We're going to give our students this other material. We want to design an experiment in which we can just see the difference by this material and nothing else. So once again, it's a controlled experiment. And this is the perfect time to ask the students to make a prediction. Okay, we just saw, baking soda and vinegar. Well, what if we try this material? What is that going to do? So we use some prior knowledge. And so this is a time when we thought it might be amusing to see what you guys think. Okay. And so now, Jessica, do I need to? Yeah. No, I can look at your screen, right? Yeah. I love that. So we're going to pop up a little poll for you. And what we're going to do is we're going to ask you, okay, if I do the same reaction with vinegar, I'm holding it up here to remind you, vinegar and calcium chloride, which is the chemical that's in damp red. If I do it exactly the same, except I just change the solid, the calcium chloride, do you think the temperature will go up? Do you think the temperature will go down? Or do you think the temperature won't change? In my classroom, whenever we were presented with a quandary like this, we always took a vote. Yeah, it was pretty common in my classroom to do something like this and then have a vote, and then we go with the majority. So
people are saying up.
Most everybody's saying up. Okay, that sounds good. All right. I mean, I do tell the students, I used to tell the students, it could be a trick, and so, and then I would sometimes get some of the more gullible students to change their mind. I'm going to do the same thing. I'm going to take my coffee measuring spoon. I think it's like a 2 tablespoon measure or something if you want to know exactly what it is. I'm going to put that in a fresh coffee cup, so I want to have the reaction with something else. And so let me close this back up again. I'll put it out of the way. Grab my my bathroom cup, and I'm going to measure out same amount of vinegar. So, one of the standards we're going to talk about is designing an experiment. And what students would have to think about is when you're designing a controlled experiment, what is the variable and what are the controls? And so in this case, our variable will be the solid that we're using. And so we've got the setup ready. I'm going to take my temperature probe. I'm gonna let me go to the meter screen so you guys can see what's going on. The temperature's a little cool still, so I'm just going to give it a little bit of energy to just warm it back up to pretty close to where it was before, so that it'll just start at the same spot. What I found with these temperature probes, if you overdo it, it'll just keep going up and up and up, and I don't want to do that. So let me see if I can get that pretty close. And I think we started somewhere around 23 the last time. So I've got it in the calcium chloride. Let's go back to the graph and make the prediction. Jess is telling me that the majority says that the temperature is going to go up. Okay, so what we're going to do, now you will notice that I auto-scaled this, and the highest temperature up here is 26 degrees. And if we're saying the temperature is going to go up, I need a little more space. So I'm going to go over here and I'm going to change the axis on the graph so that the highest value is higher than 26 degrees. So my y-axis, instead of having 27 degrees, I'll make this 100. Okay, be optimistic here. That would be kind of exciting if it went that high, but we'll see. We never know. Okay, we're going to make a prediction, and so the audience is saying that the temperature is going to go up. So the majority rules. We're going to make a graph, and we're going to just make a little prediction here, and we're going to say, well, the temperature is going to go up. I have it going up all the way to 90. We'll see. All right. So save my prediction to my graph. Okay. And then what I'm going to do is say just the exact same thing as before. I'm going to start data collection here. I've got my probe in the calcium chloride. Give it a little hit the collect button and start collecting data. So we should see the little inchworm coming across here. And then what I'm going to do is take my vinegar, pour it in. Everybody can see this. Pour it in. Hopefully that exciting reaction will occur. Okay, and I'll just stir it. And we'll see what happens here with the temperature change. Looks like the majority was right. The temperature does appear to be going up. Okay, and so I'll just keep doing this. We can compare this, even on the fly. We can compare this to the other run. I can turn that first run back on, and so we can look at that one. So let me do that. And so you can see that the temperature change does appear to be considerably higher than it was the first time. And so I used the same mass, or very close to the same mass, of calcium chloride as I did with baking soda, same volume of vinegar, the same setup as far as a cup and all that, open to the environment in this case. But you can see that this combination of materials does appear to have caused a much higher temperature change than the baking soda did, and not quite as exciting as a reaction. However, I will tell you that if you were here, I could pass the styrofoam cup around. If you put your hand at the bottom of the cup, you could actually feel the heat from this. Your body is 37 degrees, so at whatever this says, 50 degrees, this is considerably warmer. So I'm going to go ahead and stop this to be consistent with what we did before. It does look like it's leveled off. And so you can see, you can do the same sort of analysis that we did before. I'm going to turn, if I do it now, let me show you what happens. I get two temperatures here. I'm going to turn off that first run just so we don't get confused by it. So that's turned off, and we don't need the prediction anymore. We were right. Okay, so give yourself a little clap on the back. You were right. Okay, but I'm going to turn that off. And so the same sort of thing, we can look here, and our initial temperature was 24.8 degrees. So once again, we can make an annotation so that we can keep a record of that. And you might have your students, if you're doing this in your classroom, you might have your students write this down in a lab notebook or some sort of a report format. Let me slide that down here. And then we'll go over to the highest temperature. So, or not necessarily the highest, but we'll go over here to, the ending temperature, 50.9 degrees. The math is going to be a little more challenging this time. Yay. So let me write that down, 50.9 degrees. There we go. Let me bring that annotation over there so you all can see it. So you can see we have a temperature change of, help me out with the math, 25.9 degrees, considerably higher change than we had, even though the other one was a negative change. This one is a positive one, but a higher one. And you notice this time the highest temperature, the end temperature was higher than the beginning temperature. And so sometimes when things react or mix, they give off energy. This one is giving off energy. Sometimes when they react or mix, they absorb energy, so the situation gets colder. And so this is kind of just a little demonstration of how to use the probeware. The connections and things are pretty relatively simple. This data can be collected on anything. I'm doing it on a computer, but you could collect it on a phone, or you could do this whole experiment on my phone. We could collect the data on a Chromebook. There's many different ways. The company, Vernier, gives you lots of options for collecting the data. So that's the basics of this experiment: reactions in which, or combinations in which. You have temperature changes in the reactions. Let me come back to the presentation, and thank you, Jess. So she's helping me out over here to turn the screen share off. And so a couple of things before we get to the standards. I do want to mention one more thing. The idea here is to use materials that you can get relatively easily. Even the damp rid is something that you can get relatively easily. She's going to adjust it so my head isn't cut off. So, thank you. And so I encourage you to think about that, but I do also want a little caveat. Not everything that you can get easily in your house is meant to be mixed. And so if you're not certain about that, it would be very important that you check. The other thing to do is, if you're going to provide, I like to do what's called guided inquiry. You put out just a certain set of materials. But if you're going to do that, I would check with maybe a chemistry teacher, or test it yourself in very, very small quantities, just to make sure that it's not dangerous. There's certain combinations of even household materials that I wouldn't want you to do. So I don't want to tell you that, you can mix everything in your house. But, it might be interesting to try. This experiment would be perfectly safe with sugar, with salt, with we did baking soda, baking powder, or cornstarch. I mean, all of those things, this experiment would be perfectly safe with. So, if you want to extend this into some other chemicals, it might be a great opportunity for inquiry for your students. I'm talking really fast. Jess, is everything okay? Is anyone okay?
Right on time.
I just want to make sure that if someone had a question or something, you're more than welcome to chime in. A couple of things I wanted to include in the presentation. I've done a lot of these, as you might be able to tell, and almost everywhere I go, people would like to tie this into some sort of standards. And so it's hard for us to guess what would be best for the audience. So I went with NGSS. So because it's out there for everyone, even if your state may not be exactly using it, it's pretty standard for most of us. So here's a couple of things to consider. I looked this up in the elementary and middle school parts of NGSS. And so, this is the 2-PS-2, PS1-2, that's second grade. And so there's analyzing and interpreting data. There's a second grade standard that's in NGSS. Using mathematics and computational skills, you can see that there's a K-2 standard. There's also a fifth grade standard for that. So it's relatively easy to take this if you have to justify. We hear from customers all the time that they'd like to buy this, but they have to justify, in terms of standards, how it would apply in their classroom. So here's some science and engineering practices that apply to this. The other thing is just disciplinary core ideas. These ones right in the middle. There's a fifth grade standard, a second grade standard for chemical reactions. So there you've got that. I will tell you that the baking soda vinegar is a chemical reaction. The calcium chloride and vinegar is not a chemical reaction. It's a solution. So when you mix the two chemicals together, they dissolve and change temperature. So that's something that may or may not apply to your situation. But I would be embarrassed if someone took my word and then said that calcium chloride and vinegar was a chemical reaction. It is not. But you saw a very remarkable temperature change. Middle school standard for chemical reactions, the physical science standard, PS1-6 for chemical reactions. Also, there's the cross-cutting concepts. Very popular in NGSS. So cause and effect, we're mixing two things together. When we do that, what do we expect? Scale and proportion, you may have noticed that I changed the axes on the graph to rescale it. Very easy to do. So if your students need to be able to do that, they should be able to do that. Another cause and effect standard at the middle school level. The first one was at the second grade level. So these sorts of things our company is doing more and more with taking our activities and linking them to national standards to help teachers to be able to put that in whatever documentation they need to do. So what did we just do? Well, I'm hoping that we took this reaction, which especially the first one, most people probably were not too surprised by the reaction itself, and we used the probeware to sort of make it more easily to demonstrate how we would measure a temperature and a temperature change. This is, as you might imagine, having this overflow like that is very, very exciting for students. And then have a probe in there, you'll hear the students say, "Oh, look at that!" And as they see the temperature change, the hot one is one that does cause a lot of that "Oh, look at that" sort of response. And this is an opportunity here for you to inspire your students and maybe have them think. I would absolutely, and this definitely happened the last couple times I did this with kids, is questions like, what if we used more vinegar? What if we used more baking soda? Those are the kinds of questions we hope as classroom teachers that the students are gonna ask. And of course, I'll leave it to you to have to deal with the mess that comes out of that. But it's a lot of fun when that happens. So just sort of let you know about that. I did want to mention another thing. Not uncommon for folks to ask things like, well, what other experiments can you do with this probe or with other probes? Vernier, we're teachers. All of us here in the tech support area are teachers. And so what we've done is we've taken a lot of experiments that we've done over the years, and we've made lab manuals from them. There's an elementary lab manual, there's a middle school lab manual, there's renewable energy, very popular in elementary and middle, with step-by-step instructions on how to use the probes. We made, I don't know, near 100 probes, I think 90 probes or something. And so at the elementary level, last week I did an activity with some fifth graders on water quality. We used a pH probe. There's a third grade class that was doing something last year with motion, so that we used our motion detector. Kidwind is very popular, and we support that a lot here at Vernier with energy sensors and Kidwind apparatuses. So if you're curious, there's one way to get in touch with us here at vernier.com on our website. You can also contact me directly if you want to talk to me, but we have a great staff here of specialists in every area, and so we can direct your questions to those people. What do you think, Jess?
All right, we'll go ahead and do questions.
So does anyone have any questions about any of this stuff?
Oh, they do.
Okay.
I've been keeping an eye on the chat. Thank you so much for presenting news. This has been wonderful. But I did see some questions that came in through the chat, but also through our question box. So I did try to keep track of them. So I'll go through them now. One question was, does the probe come with software? So one of our attendees was asking, something like the graph that you were showing, does that come with what we offer?
Sure. Yeah, that's a excellent question. The software is free. The software runs on any platform, and you can get that software right now if you want to. Okay? It's called Graphical Analysis 4. And so that software, you can pull it down from our website. If you go to vernier.com, you'll see a download link. It says downloads, and you'll see graphical analysis listed there. So we don't enclose it necessarily with the probe. We do have when you get any sensor from us, there's a card in there that says go here and get the software. But it's free software. So if you want to see graphical analysis, the piece of software that I was just using, you can do that right now.
We did also get a question about how much these items cost.
Sure, absolutely. That's I had a limited budget for 34 years that I taught, so I know exactly what you mean. This temperature probe that I was just using is $69. The probes vary in price. It depends on how expensive it is to make the sensors. So the pH probe is under $100 at $89 if memory serves. Different sensors will have different prices, and of course all of that is published on our website. I did notice that we have some international folks in with us today, and one of the things we have an international dealer for overseas, and so but our equipment is available overseas. The other thing to be aware of that is a big thing for Vernier is that the sensors, we try to keep the price down because we know people have limited budgets. $69 might seem like a lot, but this sensor has a 5-year warranty, and the company, I'm not quite sure how we do it, but the company will repair sensors for a long time after that 5 years. So even though you might spend a little bit of a premium to get something like this, the advantage of having it for pretty much your whole teaching career and will be supported by Vernier. So it's it's part of the reason. There were other companies the whole time I taught, and one of the reasons I stuck with this company is because these things that you invest in you'll probably be using them for most of your career. In the case of many of our sensors, there's a few that have limited life, but we would certainly talk to you about that. So, okay, does that answer your question?
Great. You did mention this a little bit, but what kind of compatibility do these probes have?
So this sensor that I just used can be connected 2 different ways to almost any device. So when I say almost any device, a computer, Mac or Windows, a Chromebook, a tablet, a phone. So the way it works is I was using it, you'll notice, look, Mom, there's no wires. I was using it by Bluetooth. So I could connect this sensor to my phone, but there's some older devices that it will still work with, but maybe the Bluetooth isn't quite as good. So there is a connection, a USB connection on the back of the sensor, and the sensor comes with a cable, and you can plug it into the USB port. So one of the other advantages of these newer sensors that we sell, because we've been making sensors for a long time, is these plug straight into your device, whether it's with a USB cable or wirelessly. You don't need anything else. The software is free. You are, of course, going to need the software, but there's no other devices in between the sensor, and they're called interfaces. This sensor, all of our Go Direct sensors, the one with this distinctive color, they all connect one of those, either Bluetooth or wireless, so with almost any device that you have available to you.
And then what types of probeware are suitable for elementary and middle school students?
That's a really good question. One of the things we do with our lab manuals, am I allowed to still screen share my screen?
Yeah, you can.
Can I do that? I didn't know if I would be messing it up, but I'm going to screen share my screen, so you guys are going to be able to see this now. If you go to our website,
That's a little bit of lag.
what's that? A little bit of lag.
Yeah.
If you go to our website, and let me pull up the elementary book, what we do is we list for every one of our lab manuals, we list the sensors that you would need. And you can see that for the first, looks like 13, 14, 15 experiments in this elementary manual, you can use a temperature probe. So you can get a lot of bang for your buck with a temperature probe. And we've already worked these experiments out for you. But then you notice gas pressure, motion detector, these are very appropriate. Force is a very appropriate sensor for elementary activities. Light sensor, like measuring the amounts of light in various conditions. And so all of these sensors are listed. And let me go back up. I kind of skipped it quickly. Here is the book that I'm talking about. Every one of our curriculum books does this, where it lists the experiments and it also lists the sensors. So you can easily tell, first off, how much bang for my buck. If I buy this sensor, am I only going to be able to do 2 experiments with this, or am I going to be able to do, in this case, 15 different experiments with the sensor? The other thing about all of our books is all of our books are given to you in an electronic format in which you can change the experiments. So if you take our basic instructions, but you can then modify them and customize them if you want to whatever situation is in your classroom. So if you're emphasizing a specific point, you can ask questions or whatever. But the nice thing is you don't need to reinvent the wheel. We've invented the wheel for you. Look at all these experiments that we have written, and you could certainly take one of those experiments and modify it very easily with the instructions that we supply. So hopefully that wasn't overkill. Let me unshare or go back to the presentation. There we go. What other questions?
All right. So we actually are still getting more in the chat.
That's great.
This one just came in from Linda. Would you need internet connection while using the probe if you've downloaded the software prior to the experiment? She's thinking about specifically doing experiments outside with her 4-H club.
What a great question.
Awesome.
Once the software is installed on your device, you do not need internet. The software, depending on the device, the software will need the internet to update. So if the software changes, all the updates are free. But once it's installed on your device, no, you don't need internet. So you could get some of our sensors. There's a lot of sensors that apply to the environment. We have water quality sensors, and we have conductivity and salinity. Those sorts of things, you could go out and collect that data on your phone with graphical analysis, the software I was just using, and you would not necessarily need an internet connection.
Great. It looks like we also got a question about discounts, but I'm not sure if we have a standardized answer for that.
We encourage customers to go to our website, and there is a tool built into our website that allows you to set up a shopping cart and put anything on there that you want. And then there's a button at the bottom that says request a quote, and there's a box that says notes, and you can ask for applicable discounts. Very common question is, I've got a grant and I'd like to stretch it out. Could you possibly save me some money? And the Verniers are teachers, and they know this. They know that the challenges that we all face in the classroom, and so we do the best we can. But as far as specific discounts on specific things, I don't know. I can't give you that direct answer.
We did also get a question. We had a teacher who works with special needs kids, and just a question about, can this probe and software be used in a classroom for special needs kids?
The closest thing that we have to that is this probe can be connected to a device that we sell called a LabQuest. It's changing quickly, but that device, it's the LabQuest 2, does have a feature that allows students that are visually impaired to be able to hear the data as it's being collected. We discovered that just purely by chance, that if you turn on your own personal device, if you turn on the accessibility features where it reads the screen, the graphical analysis does get read. in voice. So you can connect this to a computer or a Chromebook. Or, I don't know about Chromebook because I didn't test it on that, but I tested it on my computer and I tested it on my phone. And sure enough, it'll read the temperatures and the buttons and that sort of thing. So yes, there is some the accessibility features on your device do get echoed in the software. So it's possible. We haven't written any specific activities that I'm aware of for special needs, but at least the software is able to address that.
So this question just came through in the chat from Amanda. Is there a probe that would be appropriate for a college chemistry lab? And then can you save the test data to a file to upload in your course dashboard? Absolutely.
Yes to every question. We do have a college chemistry section on our website. I am presenting this year at ChemEd in Chicago. We have many sensors. Most of these sensors are appropriate to almost any level temperature. We do have some more advanced sensors that measure spectrums. We have sensors that measure melting point. We have a melt station. We have a chemical polarimeter. We have a spectroscopy, different levels of spectroscopy that may be of interest. Yes, we do support college chemistry. We have a mini GC. And we do have an organic chemistry lab manual that might be of interest to you. We have an advanced chemistry book that addresses higher levels of chemistry, high school and maybe Gen Chem, first year chemistry. We have an AP chemistry book that's more of an inquiry level, high level chemistry book. So the answer to your question about college chem, yes.
All right. Well, we have more questions. So we have a particular individual that's asking about using probes for measuring gases, or specifically, he said aerosol particles. And I don't know how much we can get into example activities. That might be something we have to go offline for, but anything around that.
We don't have anything quite the level that you're talking about. We do have a gas pressure sensor that will measure the total pressure of gases. We do have an oxygen gas sensor. We have a carbon dioxide gas sensor that particularly in environmental sciences is used. But we don't have, when you mention an aerosol, if there's something specific in the aerosol that you're trying to measure. We do have a mini GC, and once again, I want to be careful with that because it's a limited device. It's designed to teach gas chromatography. So if you're looking at something very exotic, it may not serve your needs.
Okay. And then this particular question asks, can multiple sensors be linked to one device? I'm
sorry, I realized I forgot something. Okay. There was a question about data. So I'm going to share my screen again. I like this. I'm learning how to work this. I'm going to share my screen again, and I'm going to show you in graphical analysis. So this is true in all of our softwares, but this is the one I have up right now. Couple of options here for sharing data. So you can save your data just like you save data on any other program, and this is on any device, to anywhere. And so commonly what a lot of our education customers use is Google Classroom. And so the data can be shared to Google Classroom, and then a student could collect data with a school device, but then go home. If the software is free, they can put it on their home device and open it up from Google Classroom. They can also export the data as a comma separated values file that can be opened in either Google Sheets or in then Excel. They can also, something that I was just starting to experiment with when I retired, was you can take a picture of the graph, which then gets saved wherever you want it to be saved if you're using Google Classroom, and then that would be an ideal place. And then the students can then import that into a lab report. So yes, the data can be exported and saved many different ways. So that was, I'm sorry, I remembered that and I cut Jess off.
No, that's okay.
Go back and put myself back into the talk here.
I think that answered actually a couple other questions that I saw pop up. So that was a good a good one to address.
Okay.
But this one was about multiple sensors being linked to one device.
Absolutely. By Bluetooth, you can connect up to 3, I believe. So I could have 2 temperature probes. I could have had both of these connected simultaneously. We have numerous experiments in which we have more than one sensor connected, and they're not the same. So I'm going to make, by the way, if you're in St. Louis in a month, I'm going to be there for NSTA. I would love to meet some folks. I'm going to do a workshop where we're going to connect temperature probe and pressure sensor simultaneously so that we can look at gas pressures, and we're going to measure the pressure and temperature relationships, Charles and Gay-Lussac's relationship. So yes, you can connect multiple sensors. The other thing is some of these sensors, not the temperature one, but some of these sensors have multiple channels. So we have, for example, a force and acceleration sensor that you can turn both of those sensors on simultaneously. Our carbon dioxide sensor has a temperature probe built in. So you can connect multiple sensors, and some of our sensors have multiple sensors built into them.
Okay, so we're going to go ahead and keep moving forward.
Okay.
We have a few minutes left in our hour,
Okay.
so we just have a few wrap-up slides. I wanted to thank you, Nus, for presenting and informing all of us, but I also wanted to extend a thank you to all of you who have signed in and attended this webinar. We really appreciate you joining us today. And as you see on the screen, please don't hesitate to reach out to Nus via Twitter. He's active on there, and he'll let you know what shows he's at and where you can reach him. You can also learn more about us at Vernier Software Technology by going to www.vernier.com. And then there is also a survey that EdWeb would like you to fill out to let us know how the webinar went. And that's another quick reminder to go ahead and join the Teaching Next Generation Scientists community so you can learn more about the other webinars happening, maybe see us again.
I hope so.
And learn what else is going on here at Vernier and get some other ideas and collaborate with your peers. Have access to edWebinar recordings, earn your CE certificate credits, and download slides, chat logs, and get other free resources. And that's it.
That's it? Well, folks, I had a really good time. I hope I was able to convey that, and I look forward to hearing from some of you. And like I said, I will be at STA next month, so if you happen to be in St. Louis and like to stop by, I would love to meet you. I do other presentations around the country. I will be in Chicago for a chemistry presentation. If anybody happens to be there, I'd love to see you.
Great.
All right. Well, I'd say let's have a good evening. What do you think, Jess?
I think so.
All right. A lot of fun, folks. Thank you very much.
Bye.
Bye.